Good day viewers, welcome back to my YouTube channel. Today we'll be looking at the topic periodic function, and so we'll talk about what periodic function means. We use an example, we talk about some examples, and then we also learn how to locate how to get the period of some certain functions. Okay, so what is a periodic function? A function f of s is said to be periodic of period t if f of x is equal to fx plus nt for all integers n. N is an integer, so it could be -2 +2 is just an integer number, but t is the smallest positive constant for which this statement is true. So t is what we refer to as the period. Okay, the t is what we call the period. Now we are asked to show that f of s equals sin s is periodic at t equals to 2 pi. So I want us to use two different things to show this. First of all, let's use the graph. Let's look at the graph of sin x. So this is the graph of sin s. So the highest you can get is 1 and -1. This is 0. So at this point we have pi over 2, which is 90. We have pi, which is 180. Next is 3 pi over 2, which is 270. Then we have 2 pi, and so on. We have 5 pi over 2. Then you have 3 pi. Moving on, you have 7 pi over 2, and then you get 4 pi. So if you do the other side, you get the same thing, but this time negative pi over 2, minus pi, minus 3 pi over 2, minus 2 pi, and so on. But let's focus on this other side. So what is sin 90? Sin 0 is 0, so you get this point. Sin 90 is 1, so it comes up. Sin pi is 0. Sin 3 pi over 2, that is sin 370. 370, so it goes to -1. Sin 2 pi, that is sin 360, you get 0, and then you go up again, you come back to 0, you go down again, then you come back to 0. So I just want us to see what happens. So from here it goes up, it comes down, it goes up again. So after this point it goes again. Let me use a different color for that. Draw. Yes, I use red. Okay. So what can you observe? If you look at it, you will see that when we started from 0, and then when we get to 2 pi, we started a new circle. We started the same thing. See, from 0 it goes up, comes down, then come back to 2, goes to 2 pi. Then from 2 pi it goes up, come down, come back to the default set. If you continue like that, you keep on going up, coming down. So we call that sinusoidal wave. But this is periodic now. It is periodic at every 2 pi. So if you calculate the distance from here to here is 2 pi. From this 2 pi to 4 pi is also 2 pi. If you do 4 pi minus 2 pi, you get 2 pi. So that is the meaning of the period. So the period of this function is 2 pi. But if you can't see it clearly, if you look at one way of showing this, the formula says that a function is said to be periodic at that point if we can show that the f of x is equals to f of x plus nt. So this time around our t is 2 pi, so we just have to show that f of s is equal to f of x plus n, then 2 pi. This is what we need to show. Okay, so to do that, we know that f of x is what? F of x is sin s. So y f of x plus n 2 pi is what? Is sine. So you replace s by that, x plus and 2n pi is the same thing as n 2 pi. So this is what we have. So to expand this, there is a formula in trig. Let me use a different color. So there is a formula in trig for sine that says sine x plus y is equal to sine x cos y plus sine y cos s. So that is the formula we are going to use to expand that. So we call that sum of angles. So this is sine cos 2n pi plus sine 2n pi then cos x. So let's break this down. So sin s will still give us sin s. Cos 2n pi is that is cos 2 pi, and there is a 2 pi before the n. So that is just like product of 360. Cos 2 pi is 360. So n is a number. It can be 1, it can be 2. So if it is 1, it's 360. If it is 2, it's 720. So any case, whichever one we have, all will give us 1. Okay. Then sine 2n pi will always give us 0. You can see it. 2 pi is 0. If you go to 4 pi, it's still 0. So that one is 0 times cos x. So at the end of the day, we have sin x, and sin x is what? F of x. So we've shown that f of x plus 2n pi is the same thing as f of x. So that is to tell you that sin x is proof that sin x is periodic at 2 pi. So it's either you use the diagram or you show this working, but this is the formal way of showing it. But the graph is just to visualize how it is periodic. So let's add a remark. We can't show all, but you should take note of this, that sin s, cos x are what? Are periodic at t equals 2 pi. So take note of that. Tan x and cot s are what? Are periodic at t equals pi. Okay, so it's periodic at pi, while sin x and cos x is periodic at 2 pi. Now also there is something very, very important you need to know. It says if f of x, f of x is equal to f of x plus n pi, it means that f of x is periodic at what? At p, right? But now if, for example, we now have f of ax plus b, so like the x is having a coefficient, in the first one the coefficient is 1, but if you have a coefficient of x that is other than 1, so you can have even plus b. So how do you get the period? So the period now for this function, the period will be p divided by absolute value of a. So that is the period. So let's do an example. Find the absolute value is just to make sure that whatever the coefficient is, it could be negative or positive. Ensure you make it positive. Example, so say find the period. Alright, so for question 1, let's find the period of this. So what you need is the coefficient of x is a. You just need the coefficient of x, which is 3. Then the period of sine function is 2 pi. So to get the period, it is pi over absolute value of 2. So that will be 2 pi over absolute value of 3, which is the same thing as 2 pi over 3. So that is the period. Okay. So if you go to question 2, we have cos x over 2. So in this case, our a is 1 over 2. The period of cos is still 2 pi. So the period of the function will now be pi and period over cos divided by a, so which is 2 pi over 1 over 2, which will give you 4 pi. So you get 4 pi. Moving on, let's do question 3. So question 3, we have tan minus 5x. So in this case, our a is -5. Our period for tan is what? Is pi. I've given us before. So the period of this tan -5s will be p over absolute value of a, which is pi over absolute value of -5. So that is pi over 5. So that will give you the period of the tan function. Then for question 4, we have sine 4x plus 5. Okay, so the period is 2 pi, while a is 4. You neglect the 5. We don't need it for anything. So to get the period, that is p over absolute value of a, which is 2 pi over 4. So that will give you pi over 2. So that is the period for that function. So this is all for period. If you haven't subscribed, make sure you subscribe before leaving. Thank you very much.